Example 7 on page 391 is for all of you basketball fans out there. And we're going to use our equation that we just got in the last example, the percent times the base equals the amount. At one time, the 1995-96 Chicago Bulls had the best record in the history of the NBA with 72 wins and 10 losses. What percent of their games did they win? Now we have to be careful on this problem because they haven't given us the full amount of information. They've told us that they won 72 games. They lost 10 games. What they didn't tell us is the total amount of games. If we add these two together, we know that there was 82 total games, and that needs to play in here as part of our equation. Because the amount of their wins is 72. That's how many wins they had. The percent, their winning percent, is going to tell us the percent times the base. The base is 82. It's going to tell us they won 72 games there. So that's how we need to set this one up, as in we don't know the percent. So X is our percent that we don't know, times 82 is our base. It's the total number of games, equals 72. And so we'll divide 82 on both sides like we did in the last example. And we're going to have 72 divided by 82. So let's bring up our calculator here, clear off anything that may have been there, and say 72 divided by 82. And we're going to get 0.8780. And again, since the calculator's here, let's go ahead and multiply that times 100. So we can get our percentage of games won, and it looks like it's going to be 87.805. Was their winning percent. So 87.805 is their winning percent. It is more accurate than what the book has displayed, but that's still an incredible amount of games won. Moving on to example 8. It says from 2003 to 2016, the total amount of student debt has increased 429% to $1.27 trillion, or $1,270 billion. What was the amount of student debt in 2003? Now, the total number of years isn't a factor in our equation here. If you look here, we have, again, percent times the base equals the amount. Nowhere in there does it say time, so time is certainly not a factor. So the 13 years involved here doesn't mean anything to us. But what are the things that do mean something to us? Well, we have 429% is the number given. We also have $1,270 billion. All right, so they've given us 2/3 of the information, and they're asking for the other 1/3. Now, obviously, 429 is related to the percent. Is the 1270 the base or the amount? In our case, it's going to be the amount, because that's what's increased to, it said. So we're trying to figure out what it was originally in 2003 so that it could increase 429% to be 1270. Now, anytime you're talking about an increase of a percentage or a decrease, these are usually the two ones that'll get you. You have to be careful. 100% is in this problem whether you know it or not. So we don't want to use 429 as is. What we want to do is we want to go ahead and take 429% and add 100% to that. Because we have to account for the today. And these problems don't usually do that. It's kind of a hidden value. So we're going to go ahead and add that 100% in to start with and say really our percent then is 529%. The same thing would go if they told us it was minus 42%, let's say. We would take that minus 42% and add 100 before we used it as our percent in the problem. Now we want to convert 529% to a decimal. So if we take it and divide it by 100, or if we move our decimal point over 1, 2, it's going to be 5.29. It's kind of a large number, as it should be, because it's over 100%. So in our case, we're going to take 5.29. That is the percent number. We're multiplying it by a base we don't know. So again, times X, and it's going to equal the amount of 1270. So we're going to divide both sides by 5.29. And then this will be able to tell us what the cost was in 2003. Bringing up our calculator here. We are going to have, let's clear that off, 1270 divided by 5.29. And we're going to get $240.076 billion. Let's go ahead and translate that back to our answer sheet here. So that was $240.076 billion. So obviously a gigantic change between 240 billion to 1,270 billion dollars. Amazing that student debt is that out of control and headed that way. And certainly if you extrapolate that even further, who knows where this is going to go and how bad this could get.